Hey guys, we're out here at Circuit of the Americas. We're doing some testing with the Camaro and wanted to kind of talk a little bit about, working with Jason Hart. We've brought him on board to help us develop the car because a car that's that capable is very difficult for me as a driver to understand where's the boundary between the aero and the chassis, how do we tune those things together to work together, and what is the driver experience supposed to be in a car like that. All of those things are things that if you try to figure them out on your own, you're going to spend years and years and years, where I felt like it made a lot more sense to call my friend Jason, have him come on board, figure out what's the car doing, how's it working, and it's been great so far. We were really excited to run today, and you can weigh in a little bit on what your thoughts are on the benefits of using a pro to kind of help out with development on a car.
Yeah, it's a real treat to work with Mike and the whole team at Dussault. One thing they do really well is they put all the parts and all the adjustability and all the packaging together in a fantastic way. But even once you do that, even if you have a wonderful instrument, a violin, a guitar, whatever it may be, you still have to tune it. And I think that's maybe what Mike was looking for when he brought me in, and I jumped at the opportunity to take the vehicles that they engineer and assemble and fabricate and be part of the process of making everything work together. The suspension, the dampers, the aero, even we talk about how the car shifts, how it downshifts, how do the brakes work, what's the bias. We try to get all of the components of the car working in unison, and therefore the car becomes drivable and compliant. It builds safety into the car, and most importantly, it helps it turn a really fast lap time.
Yeah, you can't turn fast lap times in a car you're not confident with, and that's been kind of one of the biggest things with my experience with building a car that has that much downforce and has that much power. And now that we've got the big slicks and everything on there, the car does things to you as a person that if you've never experienced it, it's kind of throws you off a little bit. Like going through a corner at 2 Gs and having the car just stuck is interesting. Like, yes, it's very, very cool, but it also messes with your mind trying to just keep your eye on the prize and what you need to do when a car is doing that. So I think it's been great working with you, and I'm really looking forward to doing it going forward to get the car better and better and better. Unfortunately, today we made a little bit too much downforce. Well, there's no such thing as too much downforce. But I think there were some loads that we didn't really realize were going on in the front splitter, and unfortunately we broke the front splitter. So we're going to have to, make a badder, stronger splitter. We already have another design we're working on, so I'm not really that sad that that splitter got broke. But we'll definitely need to talk with all of our friends and engineers and figure out, okay, what exactly was the load that caused that thing to fail? And I guess, I know from my experience, I could tell that it feels like the tires take a set, and then the aero almost feels like it squishes them even more, like you could feel that. What's, from your perspective, can you put into words, how do you look for the downforce in a car? What makes you able to feel downforce?
There's a couple things, but basically it's the front to rear axle interaction and how the balance of the car changes as the speed increases, right? So we know at lower speeds we're making lower downforce levels in most cars. But this car, even at 60 miles an hour, I don't know what the number is, but it's making a significant amount of downforce. So in my mind, I'm always trying to interplay the feeling mechanical grip versus aero balance, and then obviously they're linked together because they're happening at the same time. But there's things that you can do in making a diff adjustment, or making a wing adjustment, or changing the rake of the vehicle, or changing the spring rates, or playing with the bars, that can tell you if that environment is more mechanically influenced or more aerodynamically influenced, also what the balance is. The other thing that Dussault's doing a great job of is they're putting in professional motorsport wiring systems and data collection systems. And what that does is allow them to gather a ton of data so that they can then go model the car post-session, and it can tell you what the aerodynamic loads are on the front and rear axles, what the roll rates are, what the attitude of the car is, and through all of that you can also, from an engineering standpoint, without you know, just relying on driver feedback, you can balance what the driver said with what the data says and the engineer says. And when you start to work the two together, that's how you really try to, or start to sharpen the instrument and make it quite good. And it's a lot of fun. It's fun to get to be a driver brought into one of these programs, because in pro motorsport, everything is kind of established. There's not as much discovery in pro motorsport, where these cars are 100% discovery, right? Huge engines, huge tires, big downforce. In your case, a 67 Camaro that's R carbon bodied. You know, you're getting to play with something that you can really open your mind up and try things and make things and modify things. It's quite fun.
Yeah, we've had a lot of fun with it, and it's one of those things, you know, some people, you know, get embarrassed if something fails or there's something that doesn't work out the way that they thought it would. And I feel like it's important to be open to that. You know, you're never going to be able to build something like what we're trying to do without accepting some risk of some stuff not working out the way that you wanted. So this weekend, the splitter failure is definitely a negative, but I'm really excited to go over it with my friend that's, you know, Brian, has been a composite engineer for a long time, and go over the failure, because we're going to learn some really good stuff from this. You know, we used materials that are used in aerospace to put composite structures together. The fact that it failed is very interesting to me, because I would have thought that that thing would have handled crazy loads. So the thing that's kind of coming to my mind that might be the actual source of the failure is the bumps here, right? So there's some high G-loaded areas with a lot of bumps. And my curiosity is, what is that, when you load that thing up with, say, 1,500 pounds of aero load, and then you shake it in the bumps, what do those spikes in load do? You know, maybe we were seeing, you know, spikes that were up to double the load. And when we were considering building the splitter, we're considering what's the total aero load of the car going to be at maximum speed. Never really crossed my mind to go, well, you need to really throw in what's going to happen when you go through a washboard of bumps in a braking zone in that speed with that load. So my initial gut reaction is that something like that's what caused it, or some kind of an impact. But like you say, we have data. So we'll analyze the data, take the car apart, figure out what's going on. But it was really cool to hear you say that it felt like it was loaded up a lot.
Yeah.
So that's actually a good thing. It means that the potential should be really high. And the funny thing is that the new splitter design that we've been working on with Virus Engineering is actually more downforce than the one that we just had on there. So we're going to really have to be careful of the loads, because it's definitely significant. You know, that amount of a load, you know, and we didn't fail it at 200 miles an hour at Road America repeatedly. It failed, you know, multiple times after. So maybe it's just one of those things that just, we got to build it just a little bit stronger so that it's not fatiguing or something like that. But I'll make sure to put it on a video what we find and discover, because I know that there's at least 2 people out there that are interested in how that stuff works. I know it's cool to me, and I really wish we were going to get some time to do more work on the car. I think we'll have to come back in the spring, but I guess we could touch on another thing that I think is going to be really interesting in the spring, and that's going to be the 3rd spring. And I think that 3rd spring is going to probably help a lot of that feeling of the car just being bound up, because we'll be able to get it where it's not necessarily sitting on packers. We're going to try and get it where it's on that 3rd spring, so that we can get a little bit of compliance and travel it a little bit less. So in theory, all of what Scott's been telling me about how great that's going to be, I'm super excited to see what it does. What's your thoughts on the 3rd? Do you think the 3rd is going to be a game changer for the car?
I think from an engineering perspective, it gives a lot more options, right? Because you're able to maybe run a little less outboard spring and a little more inboard spring, so that the inboard spring is handling more of the Z-axis pressure from the aerodynamic load, if I understand it correctly. And our corner springs, if you will be more road compliance. And I think you'll have a lot more options there too when it gets into the 180, 190, 200 plus that we've quietly already recorded in the car on a straightaway. we're going to need different spring values at 200 plus as we're going to need at 100, as we're going to need at 60. And I think Scott and you, from an engineering perspective, you're just going to have more tools. You're going to have more options to make sure the car has what it needs on a spring-based standpoint at all of those speed ranges. Because when you're playing with the car that has the capabilities as a car like this, you need a variety of tools built into the car that are adjustable so that you can get the car to be well behaved and capable at all of these different speed ranges. And one of the things we're talking about is when you're creating 3,000 plus pounds of downforce, which from a CFD modeling perspective, this car does quite easily. That takes your static ride height and just lowers it and lowers it and lowers it. And if it gets down to where you're coil bound or your bodywork splitter maybe impacting the ground because it's pushing down so hard on the car, you have to find a way to engineer your way around those environments to keep everything in a working condition instead of a coil bound or a floored condition, which breaks things.
Yeah, Scott doesn't like to be infinite on spring rate. It kind of tends to make loads go really high.
Yeah.
But yeah, I'm super excited to continue the development, and I know we're going to be bringing you in on some of the other car projects that we're working on. So we'll make sure to keep everybody posted on all the other cars that we're working on and developing. We're kind of trying to have a whole den of monsters and all these crazy car projects, and it's a lot of fun, and it's been great working with you. Definitely glad that we decided to work together on those projects. And heck, most of the guys that we know, that our engineering friends, are all people we met through Jason. So it's kind of come full circle, and now we've got like a whole team together that's working on these things, and it's really fun for me to learn a little bit from everybody, you know, because nobody knows everything about everything. So having like you that can help with the driving part and understands all the dynamics there, and then Scott that's just an engineering whiz, and Tim that does the data, and you know, Brian that knows all the composites, and all these different people we get to talk to. It's been super, super fun, and I think the sky's the limit. I'm really excited to see what we can do with the car next year, now that we've kind of got a good base to start from. All the stuff that we can do from here going forward is going to be so much fun, because we can just, shoot, we can take it as far as we want.
Yeah,
you know, and that's I think what has been appealing to a lot of the, you know, the guys like Scott and Tim and all them that come from pro racing, is that this is really fun because there are no rules. It's well, there are some rules, not many. And we can do anything we want to do, and that makes it so, so much fun. So thanks again, man.
Yeah, pleasure driving with the Dassault guys, working with Mike. Do yourself a favor, if you're ever in Dallas-Fort Worth, stop by Dassault Designs. It's a really cool place. I think it would blow most people's minds how much they do there with the paint shop, the composite shop, the dyno, the chassis room, everything that they do, the paint, you know, the killer paintwork that they do. Really amazing place. And ask questions. If we said anything in this video that kind of piques your interest, we're all car guys. Ask questions, reach out. Happy to chat about it.